we now discuss the solution of a problem from the section Mathematical Reasoning. This question is on the concept of tautology. This question has appeared in the Joint Entrance Examination Main held on 26th June 2022 in the second shift. The given problem is, let R belongs to the set consisting of the statements P, Q, negation of P, negation of Q, be such that the logical statement R, negation of P implies P and Q in brackets R is a tautology. Then R is equal to. We are given four options. Option A, P. Option B, Q. Option C, negation of P. Option D, negation of Q. So we are given this logical statement. In this, we have to choose R from this set consisting of P, Q, negation of P, negation of Q, such that this logical statement is a tautology. So for which of the R from this set, this logical statement is a tautology? We now discuss the solution of the problem in detail. We want to find R belongs to the set consisting of these four statements P, Q, negation of P, negation of Q, such that this logical statement R negation of P implies P and Q or R, P and Q in brackets or R is a tautology. Agreed. So first we take this logical statement and write its equivalent logical statement. Right? So now we take the statement, and use this equivalence. P implies Q is logically equivalent to negation of P or Q. So this is the first one. First one implies the second one. First one implies the second one is logically equivalent to negation of the first one or the second one. So logically equivalent to negation of the first, this one, or the second one. Agreed. Right. Now we use for this negation of P or Q is negation of P and negation of Q by De Morgan's law. So the negation of first or second is logically equivalent to negation of the first and the negation of the second. So now negation of R and R becomes and negation of P or the second statement. Now we know use the negation of P is equivalent to P. Agreed. So that will be logically equivalent to negation of R and P or the second one. Agreed. Now we use the distributive law. The distributive law is negation of R or the second one and P or the second one. So that is negation of R or this the second one, and P or the second one. That is the distributive law. Now use the associative law, commutative law, because all are valid, and bring negation of R together with R, negation of R together with that. And here you use the associative law. So that is in this we use commutative law, and in this associative law. Associative law means P A or in brackets B or C is equal to A or B in brackets or C. So this will be use the associative law. That is negation of R, P and Q. And now use the associative law. P and Q in brackets R, P or R. Agreed. And negation of R is always a tautology for all values of R. So that is T. And here we use the absorption. P or P intersection Q is P. That is what is called absorption law. So this will be logically equivalent to T or T means truth value T, true or tautology, or P and Q, and use the absorption, you get P or R. Now, T or P, for any statement P, the truth value is T. So this is T only. And here P or R, P or P is P. That is idempotent law. So this is T and this is P or R. P or R. Now use T and any statement P is logically equivalent to P. That means the answer is P or R. So the given logical statement is equivalent to P or R. We continue in the next slide. So we have this given Boolean expression is equivalent to P or R for all truth values of P, Q, R. Now, for what R coming from this set, is this given statement, logical statement, is a tautology? It's very clear now. If you take R as P, it will be P or P will be P only. P takes a truth value T and a truth value false. So it is not a tautology. And a Q also. So also. And it is very easy. If R belongs to this set, where R is negation of P, you know P or negation of P is a tautology always. So if R is negation of P, then the given logical statement is equivalent to P or R, that is logically equivalent to P or negation of P, that is a tautology for all truth values of P, Q, R. It gives you the truth value T for all truth values of P, Q, R in the given logical statement. So, thus, the given statement in which R is there is a tautology when R is a negation of P. So, let's look at our options. Our answer, R is negation of P, for which the given logical statement is a tautology, is negation of P. So, our answer to this question is option C. Now, I will add one point here. Sir, what if I make use of truth tables? The answer is that you will be making truth tables for various choice of R. So how many choices are there? 4 choices. So 4 choices you have to take and write down what are called the truth tables for this Boolean expression for various choices of R. That means 4 times you have to do. In that, only once will give you T. Therefore, it is a tedious situation. In the examination, that much of time may not be possible. But whereas if you use logical equivalences using the formulae that you have and the properties what you have, and that will bring you a straight answer with least effort. So that's the advantage with this method, and that is the detailed discussion of the solution of the problem on the concepts of tautology from the section Mathematical Reasoning. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.